classes not only store primitive values, but also provide methods to retrieve them in different formats. Every wrapper class has a method to extract its primitive value. Numeric wrapper classes, byte, short, integer, long, float, double, inherit this method from the Java number class. Why it is useful? Converts a wrapper object back to its primitive type. Allows flexibility when performing calculations. Useful when passing values to methods expecting primitive types. Okay, let's continue with our code demonstration. We're going to retrieve the primitive value from the wrapper class. Okay, so we're going to create a boolean. I'm going to call this bool obj because it's an object, and we're going to assign value true. Okay, after that we are going to create a boolean value. This is a primitive. This is a wrapper class. This is a primitive. Okay, this is a bool value. We are going to call in this one and boolean value. Okay, after that we are going to print this. So bool value, okay, let's print this. Okay, true. Nice. Let's continue. Let's create a character wrapper class char obj. Let's assign letter a. Okay, now let's create a char. This is a char value. Let's call char object, then char value. Okay, now let's print this. So let's print this. Okay, nice. Let's comment this. Okay, let's continue with numeric wrapper classes. Let's start with byte obj, make it 10, then short obj, let's make it 100, then we have integer obj 1000, then we have long obj. Okay, after that let's create a double. Let's make a float obj. This would be okay. Finally a double obj. This will be okay. Now we'll create the primitive variables to store the wrapper classes. Byte value. Okay, then we have short value, and let's call short object short value. Okay, then we have integer int value, integer object int value. Okay, now we have long value. Let's call the long object, and let's call its method long value. Okay, after that we have float float value. Let's call the float object. Let's get its primitive value. Okay, then we have double value. Let's call the double object in its method. Okay, let's print this. Good. These are the primitive values. Let's continue. Passing string value to primitive type. Sometimes we need to convert a string into a primitive data type, like int, double, or boolean. Java provides static utility methods in wrapper classes to achieve this. The format is the following. Boolean, we have pause boolean. Integer, we have pause int. Double, we have pause double. Long, we have pause long. Okay, let's continue. We're going to create an integer called in value, integer perhaps in, and let's give it a value of 100. Okay, after that we will have a double, will be double value. Let's call the class value and perhaps a double. Okay, and here we have 12, 40, 35. Okay, now let's continue with long, long, long value. Okay, let's use the wrapper class. It's long, long, perhaps a long. And here we have a very huge number. Okay, then we have a short, short value. Let's call that short class, wrapper class, perhaps a short. And here we have 45.67. Okay, now let's have a byte. Okay, now let's create a byte variable, byte value. Let's call the byte wrapper class, perhaps a byte. Okay, and here we have 120. Okay, now I'm gonna print this. Okay, now we have the values. So these are numeric values now. They used to. Let's comment this. Okay. Now let's check an example using boolean. Okay, have a bool. It will be true one, true one. Let's call that boolean wrapper. Boolean, boolean, perhaps a boolean. Here we have true. Okay, this will be bool true 2, and here we will write because this is case insensitive, which means we can write like this. Okay, let's print these values. Okay, okay, let's continue comparing objects of wrapper classes. How to compare wrapper objects? In Java, wrapper classes, integer, double, boolean, they're all objects, so they don't behave like primitives when compared. There are two ways, using equals method and using the comparison operator. Okay, equals method is content equality, and comparison operator is reference equality. Okay, let's check that. Using equal methods, compares the actual value stored inside wrapper objects. Always use equals for value comparison of wrapper objects. Then we have, using the comparison operator, compares memory reference, where the two objects point to the same memory location. This works fine for primitives, but it's kind of unreliable for wrapper objects. Important rules. Always use equals for comparing values inside wrapper objects. Avoid use this comparison operator unless checking if two variables point to the same object. So, Java caching mechanisms in wrapper classes. To optimize memory, Java caches wrapper objects for small integer values. So, cache range for integer, short, byte, and long begins at negative 128 until 127. Then we have cache range for character 0 to 127. Booleans true or false, they always catch, doesn't change. For float and double, there's no catch. Okay. How does this affect comparisons? Inside the catch range, Java reuses the same object. Okay, this comparison operator returns true because the reference is the same. Outside the catch range, Java creates a new object every time. If we use the comparison operator, it returns false because the references are different. Okay, let's try to understand what is a wrapper class catch. Okay, Java catches certain wrapper class objects to optimize memory usage and improve performance. Instead of creating new objects every time, Java reuses pre-existing objects for commonly used values. Which wrapper classes use catching? We have already checked that, right? We have integer, byte, short, long. This is the range. Then we have character from 0 to 27. Then we have boolean. I'm sorry, boolean. They always catch, only true or false. Float and double does not catch. How does catching work in Java? When you use value of autoboxing, okay, Java checks if the value is within the catch range. If yes, if so, it returns the same pre-catch object. If no, it creates a new object in memory. Where are wrapper objects stored? This is a very interesting question, and by the way, this is a very common interview question also. Wrapper class objects are stored in the heap memory, specifically in a special area called integer cache, or similar caches for other types. There is a kind of similar place in memory called string pool for string letters only. This allows Java to reuse objects efficiently. How does Java manage wrapper objects in heap? Heap memory, the main area where objects are stored. Remember that in Java we have two types of memory, stack memory and heap memory. Heap memory for the objects, right? So every time you create an object, these objects are located in heap memory. Then we have the integer cache. This is a pre-allocated pool, a pre-allocated place of objects in the Java manages inside a heap. Then we have garbage collection. If an object is not cached, if an object is not cached, it remains in the heap until garbage collection removes it. Okay, what are the key difference using new integer and versus integer value of? Okay, new integer, always, always, whenever you use the new keyword, you're creating a new object, a special place in heap memory. Okay, every time you use new integer, a new object is created in heap memory. Even if the value is the same, each object is different, not catch. Memory inefficient, yes, that's true. This is memory inefficient, as it doesn't reuse objects. Integer value of, okay. This uses object catching. So integer value of uses object catching for values. We know already that if the value is in this range, it returns an existing object from catch, not a new one. Efficient memory usage because catch objects are reused instead of creating new ones. Okay, let's try to understand this. This is heap memory in Java. We know that in Java we have stack memory and heap memory. Okay, so I want to create a integer wrapper class, okay, with a value of 100. I put it here, okay. I name this I1, okay. Now I want to create another one of type integer, another wrapper class of type integer with the same value, 100. So I want to call this I2. But is this correct? I don't think so. You know, JVM, the Java Virtual Machine, checks, okay, another object is created with the same value, is in the range, is within the range, okay, it's within the range. Do I need to create another object? No, Java Virtual Machine does not create a new object. So, what happened? In here, it creates a new reference, like this. So, I1 and I2, they both point to the same reference in the memory. I1 and I2, they both point to the same reference on heap memory. Okay. Okay, let's now create a new object using the new keyword operator. Whenever you use the new keyword operator, a new object is created. I will repeat this. Whenever you use the new keyword operator, a new object is created. So I3 is a new object. The value is 100,
It's within the range, but it's a new object. I4 is the same. It's a new object because I'm using new operator.
Okay, let's continue with autoboxing. What's autoboxing? Autobox Autoboxing is the automatic conversion of primitive data types like int, char, double to wrapper class objects like integer, character, double. This occurs implicitly when you assign a primitive value to an object of the corresponding wrapper class. Java automatically wraps the primitive value into its prospective wrapper object. What is unboxing? Unboxing is the reverse process of autoboxing. It happens when a wrapper class object is converted back to its corresponding primitive type. Java automatically extracts the primitive value from the wrapper object when needed in a context where a primitive is required, like for example arithmetic operations.